Good morning or afternoon, and welcome to the FERC 881 Compliance webinar, Getting Ready the Right Way. We have a great lineup today with experts from GE Vernova and Infosys to cover not just meeting compliance by July 2025, but to solution more to help solve the congestion issue in transmission and increase renewables onto the grid. We encourage the audience to ask questions in the chat and have allotted about 15 minutes for Q&A at the end of the presentations. You can also leave feedback and request a meeting with one of our technical experts in the bottom of your browser throughout the session. So with us today, we have Dan King from GE Vernova. Dan is a senior solution consultant representing both EMS and WAMS application suites and has been at GE Vernova for 2.5 years. Prior to joining GE Vernova, Dan worked for 17 years at a large utility in the Transmission Operations Department, working on special projects with NERC, CERC, NATF, which included NERC compliance, TADS data collection, alarm management, human performance initiatives, as well as day-to-day operational support. Next, we have Dragan Trifanovic from GE Vernova. Dragan is a technical product manager who began his career in 2011 installing vibration monitoring systems, commissioning System 1 servers, integrating to plant historians, Mark VIE controls, servicing turbo machinery equipment, and balancing gas steam turbines. Recently, Dragan has been leading transmission, distribution, and satellite analytic product development for the GridOS portfolio. And in regards to FERC 881, Dragan owns the new GridOS DDLR product, which will be demonstrated as part of the solution offerings in today's webinar. Next, we have Srikanth Srinivasan from Infosys. Srikanth leads the energy transition practice at Infosys, focused on delivering decarbonization solutions to the energy sector and energy-intensive sectors. He has over 25 years of management consulting and digital transformation experience across industries and has been focused on utilities for the last 10 years. He's on the board of Stanford Bits and Watts and a frequent speaker at industry events on the role of digital capabilities to accelerate the energy transition. And to round out the group, we have Matt Lanzini from Infosys. Matt is an experienced leader with a 25-year career bringing solutions to market and leading cutting-edge technology initiatives for Fortune 500 and mid-market utility companies. Matt has been a trusted advisor helping organizations navigate change and has managed large-scale cross-functional transformation programs across the industry. So with that, I'll pass it to Srikanth to kick us off. Srikanth?
Thanks, Doug. My name is Srikanth Srinivasan. I lead the energy transition practice at Infosys. And as we build the practice out, we've been really looking to build partners who actually complement our capabilities. And we're very fortunate to have put this partnership together along with GE. GE is a very well-known space in the utilities world, and they have deep expertise and platforms in transmission distribution, as well as a very solid roadmap for how to evolve these capabilities to support future needs. When you combine GE's platform capabilities with what Infosys brings, again, very recognized and a trusted transformation partner, as well as a world-class SI in the utility space, and we believe we can actually bring together complementary capabilities to deliver greater value to our utility clients. And we're going to use FERC 881 as an example of how we're going to bring our complementary capabilities together. So when you look at energy transition and every scenario for how you achieve net zero, one thing is very clear, that electricity becomes the dominant energy currency for the future. And when you have to drive greater share of renewables and be able to actually incorporate electric vehicles, incorporate greater battery storage, grid orchestration takes center stage. Now, if we can get grid orchestration right and provide the grid with the capabilities to deal with the scale and complexity, you're going to be able to enable energy transition. But we're already beginning to see that there are issues with grid congestion, as well as the curtailment of renewables, which is clearly not a good thing. And they are being driven by the rapid growth of variable renewable capacity. And this is happening in areas that are not where traditional generation used to be. We have pretty big shifts in load patterns. So if you look at electric vehicle charging on highway corridors, it's actually going to happen at places very different from when the transmission planning assumptions were made. There is also a much greater correlation between when peak generation is happening as well as the availability of grid capacity. So given these, utilities and transmission operators have a few options. I'm kind of referencing a fairly popular, well-known study that PPL put together, where they look at the multiple options that utilities have. And clearly, dynamic line rating, which is really a classical non-wire solution, emerges as a great option where you could actually implement something fairly quickly. You're not actually putting in massive amounts of money towards investment build-out. You have no outage required as you actually go through the process, but you still get a pretty big bump in terms of transmission capacity. And we see this as just one example of where digital can actually enable the existing infrastructure and the investments in the existing infrastructure and to actually get more out of them. And as we look at this area and digital DLR, we would encourage transmission operators to not just look at FERC 881 compliance, which is incredibly important, but to actually look at building a digital DLR capability that goes beyond FERC 881 compliance, because there are so many more benefits you could accomplish if you think about it beyond the compliance itself. And some of the key elements of that are, first, being able to look at and rely on external data that's actually coming in, external feeds like real-time weather data, just as one example. To be able to develop and refine on an ongoing basis the rating models that you need to be able to deliver these ratings for line rating. And eventually also a very reliable and low latency network infrastructure. So you could actually get all this information back in a timely fashion. The second thing we're going to look at is taking a total system approach, where you look not just at what you need to do to accomplish and comply with FERC 881, but to look at the entire system to be able to actually build a network model that you could rely on and make sure that the quality of that network model is something you could trust. The second part is to make sure that all the components that are attached to the transmission line are also captured. And we've seen with work we've done with other utilities that while transmission line is the one that has the biggest impact on the rating, there are others like the busbar connector or the terminal connectors, which also have a pretty big impact. And so to be able to understand what's connected, and if you have to go ahead and upgrade the rating on some of the other components attached, that's something that is also going to be critical to be able to have access to that additional capacity. And finally, people, like always, being able to work with the internal and external stakeholders so that everybody's trained on the new methodology and how to operate, as well as people also start building trust in the rating that's provided by the system. It's going to take a leap of faith, but you have to support that by being able to create, the reasonability parameters, and over a period of time, you're able to build greater trust to say, look, the calculations that the system is throwing up is something that you could rely on. So focusing not just on the data and the system angle, but also on the people side is going to be very important. And the benefits are fairly obvious. In addition to the compliance to FERC 881, it could create reduction in congestion, make sure that renewables, which are so important, are not curtailed, as well as defer capex, and you're able to utilize some of the benefits of this right away. With that, I will hand off to Matt, who will get into a little bit more detail around how we look at putting these solutions in place.
So I appreciate that, Sri. And as you mentioned, we really need to consider the implementation of any solution in a broad, holistic fashion, and nothing operates in isolation. And when we think about AAR and DLR, we really look across four foundational pillars: the technology aspects, the process, the organization, as well as assets. And we use this maturity model as a guide as a set of guideposts to help us identify the roadmap and the gaps between where an organization is today and where an organization is looking to head in the future. So if we take, for example, an organization that's currently using seasonal line ratings and wants to move to be in compliance with FERC Order 881, this may require an investment in new software, data feeds, the development of new business processes and workflows, require new training and materials and skill developments across the organization, and even possibly an investment in physical assets like field sensors or additional localized weather data. But having that purview of where you are today and where you want to head to is what allows us to lay out the roadmap and plan for how you get to not just compliance, but potentially beyond compliance in the future. So we use this as a tool to structure our thought process and drive that planning. And to take that a little bit further and look at it from a system standpoint, platforms rarely operate in isolation. Utilities have large, complex, interconnected systems that need to communicate with one another. For example, for AAR and DLR to deliver the value that's expected from these solutions, data has to be measured, captured, transported over networks, analyzed, and then actually leveraged to make decisions. And it's this integration that really enables the software platform to perform and execute and drive the value propositions through dynamic line rating and ambient adjusted ratings. Bringing this broad systems view together, evaluating the upstream and downstream systems, the data, is really critical to driving successful outcomes. If you think about it, there's the old adage, GIGO, garbage in, garbage out. So legacy data systems that may be out of date or have missing information may require remediation, and that has to be thought through, and those integrations need to be very, very tightly coupled in order for this to succeed. It's an end-to-end purview that needs to be thought through, and that's really where we look to come in and evaluate the upstream, downstream, and apply the knowledge set of the industry and the industry software to make sure all the data sets are there to provide the expected outcome. I don't know if folks like the Far Side, the old comic strip, but there was an old Far Side comic where someone's standing in front of a crowd and they ask, who wants change? And everyone raises their hand. And then follows up with the question, who wants to change? And nobody raises their hand. Change is hard. It can be disruptive, it can be uncomfortable, and it's a big part of moving forward and driving solutions. The change management aspect of an implementation of new softwares, new systems, is a critical step that often becomes an afterthought. So we utilize a change methodology and a change evaluation matrix to identify the areas where change is going to occur, evaluate the impact and scale of that change, and then develop the appropriate plans to help that change occur in a smooth fashion. And when I talk about the change management elements, it's really about bringing forward awareness of the change, the benefits, providing end users with the tools and training they need to succeed, and establishing feedback loops so we can course correct and adjust. But this is a critical element, and all of these pieces need to be thought about in an integrated fashion and be part of an implementation strategy. So when we look at an implementation at a high level, a roadmap, we think about it along these three buckets. The first one being early phases, assessing the current environment, evaluating where an organization is, where you want to head, where the gaps are, designing the solution, and then taking that and turning that into an MVP. And the minimal viable product really, in my mind, is an opportunity to field test and rapidly get feedback so we can get adjustments from your environment, your systems, your circuits, and make the proper adjustments before we go to scale. We want to learn quickly early and apply those learnings. And then last but not least is looking at the scaling and sustaining. So how do you bring this across a broad service territory? How do you maintain it once it's in place and operational? What are the structures that need to be in place? So we look to help our organizations and structured our services really around these 3 stages of a scaled implementation. And with that, I'll pass it to Dan.
Thank you, Matt. So I am Dan King. I'm a senior solution consultant with GE. I'll be walking us through our GE Vernova solution for the FERC 881 order. So just a little background on what the FERC 881 order is. Traditionally, utilities have used facility ratings that are based on typically seasonal base. So seasonal as in summer, winter, spring, and fall. So some examples are, traditionally a summer-based rating might be based on a 40 C ambient temperature with some known wind speeds and directions. And then your winter would be based on a 10 degrees Celsius with known wind speed and directions. So really the traditional rating systems don't take into account any of the weather-based conditions of, changes in ambient temperature or changes in the wind speed and direction. So really they're kind of a conservative rating set that limits the overall capacity on the transmission system. So this limiting of the capacity on the system has unnecessarily driven up the congestion costs of transmission across the United States. And so FERC has made an order mandating that you have to have at least at a minimum ambient adjusted ratings implemented as a transmission owner. So that means that for minimum of compliance, you would need to have 5-degree incremental rating sets, 5-degree Fahrenheit incremental rating sets across your footprint that reflects at least hourly the temperature change. And then they also mandated that you have to have a 10-day forecast for 24-hour periods looking into the future so that your forward-looking studies and generation commitments reflect whatever the real-time ambient conditions will be over that 10-day period. So GE has multiple software solutions that are going to help comply with this FERC 881 order. Let's first start talking about the EMS-based one. So our EMS-based solution essentially is going to take your rating sets. So your rating calculations, those can come from field-based dynamic line rating sensors or GE's digital dynamic line rating sensors. Dragan will be talking about that in a little bit. It can have a ambient adjusted rating set table or a polynomial equation to define your ambient adjusted ratings. Your traditional seasonal based ratings is like a fallback method, and we'll get into that later in a demo, and then your nominal ratings. So essentially the EMS based solution is called RTOs or dynamic ratings, but it acts as the limit management system. So it enforces the limits that are in effect for both your SCADA and your network applications. It can also feed in the rating sets into our multi-time point look-ahead applications. And then we also have the ability to transmit or communicate those ratings to either your neighbors or your ISOs, et cetera, all from our EMS-based solution. But it's basically the minimum that you would need for compliance, and it can pull data from your dynamic line ratings or from your ambient adjusted rating tables, et cetera. So a little bit about how the application works. It has a feeder of incoming rating sets. So these ratings can be manually entered operator ratings. They can be, like I mentioned, the telemetered, which would be your digital dynamic line ratings from our GE applications, or field-based digital dynamic line rating applications, your ambient adjusting rating table, et cetera. Basically, it's looking at all of the hierarchy of controls of those different rating sets, and based on the telemetry or data quality, it's going to pick the highest priority with the best data set and put that rating set into effect, and then drive that rating into SCADA and all of your network applications to make sure that you're always operating to the most correct, best quality data of your ratings. It also supports real-time and your forecasted rating data exchange. So with the FERC order, you have to have a real-time rating set and also forecast a rating set over your next 10 days. That has to be communicated with your neighboring TOs and your ISOs. And so we want to make sure that we're having those rating sets always in effect. And then we want to store those rating sets. I believe there's a requirement to have those ratings per the FERC order. So from an EMS perspective, for our roadmap to FERC 881 compliant with customers, our platform version 3.5 is going to be fully compliant with FERC 881. So every customer that upgrades to FERC to EMP platform 3.5 is going to receive the functionality of the RTOs application, which will give them FERC 881 compliance. There'll be 2 new licenses required, one for the dynamic rating or RTOs application, and then another one for the dynamic rating forecast. So that's the application that will provide the 10-day, 24-hour period forecast. And then for the Reliance customers, the second release this year, 2023, so our 2023.2, will be fully compliant to FERC 881. And then there'll only be 1 license required for dynamic rating, and that'll include both the real-time and forecast. And any customer that's staying on a previous version will have the ability to enhance their solution through add-ons or backporting in order to make sure that they're also compliant. So we want to make sure that all of our current customers are compliant with the new FERC 881 order. So looking at another application, so if we want to extend the FERC 881 with our Grid OS application, so our grid orchestration software, that's our microservices-based applications. So our digital dynamic line rating is based on Grid OS and microservices. And essentially, we're able to unlock capacity on your entire footprint with the software solution without installing any of your traditional hardware-based sensors out on your transmission lines. So the digital DLR is going to combine all of your GIS, EMS, asset data, et cetera, so that you have a much more representative rating set on your transmission equipment that's based on the real-time ambient conditions. So the EMS-based solution, at a minimum, you would use an ambient adjusted rating table. So it's only using the variable of the ambient temperature. So you're getting a small amount of gain over your traditional line ratings. Whereas with GE's digital dynamic line rating, you're taking into effect not only the ambient temperatures, but also the wind speed, wind direction, irradiance, et cetera, so that you get the full cooling effect on your transmission lines, and you get the maximum capacity available out of those transmission lines, which will greatly reduce the transmission congestion on the electrical grid. In addition, by going to a digital dynamic line rating, you essentially unlock dynamic line ratings for your entire footprint without installing a single sensor, and you future-proof your system because FERC has already moved on to doing a inquiry on using dynamic line ratings across the grid. So you'd essentially future-proof your system by installing a digital dynamic line rating application. So for a minimum compliance for the one on the left, our ambient adjusted ratings is our dynamic rating application. It meets the FERC 881 requirement. It does increase the line capacity approximately about 11%, but it doesn't increase the capacity compared to other solutions. Our digital dynamic line rating gives you ambient adjusted rating increases of up to 33%. It's hardware free, low installation, low maintenance cost, and basically the single software installation can unlock capacity across your entire footprint. And then your field-based dynamic line rating sensors, they can increase because they've got a lot more granularity with the data that they're collecting, about 7% above the digital dynamic line ratings, but they're more expensive and there's a lot more downtime and a lot more installation costs. And then there's a future, overhead and maintenance cost of maintaining those devices in the field. And then lastly, to kind of fill out the overall FERC 881 solution is our limit exchange portal. Smaller utilities will probably be able to use ICCP data connection in order to transmit their rating sets to their neighboring TOs or to their ISOs. But we've developed a limit exchange portal that's in direct response to the FERC 881 order. This is we believe that the larger TOs and also the ISOs who have a huge volume of data of all of these rating sets, especially the 24-hour, 10-day forecast volume of data that they're going to have to collect, and it has to be stored for 5 years. The limit exchange portal is going to transmission of that data back and forth between those companies, and it's also going to be the archive for all of that data. So that mandate to have 5 years worth of ratings saved, the limit exchange portal will be a place to store all that data for future audits and data interrogation. And then lastly, the limit exchange portal. So it's basically, it's a way to exchange your ambient adjusted ratings, or also to exchange, if you're using digital or dynamic line ratings, to exchange your real-time ratings between your ISOs and TOs. It allows you to store that data for historical purposes, make sure that your limits are always in effect, and that both your ISOs and TOs everybody's using the same rating at the same time, so they're all controlling to the same value. We've got interfaces supported in the limit exchange portal, and then also the ability to push or pull those rating sets between EMSs and market systems. So with that, I'll turn it over to Dragan for his demonstration of the digital dynamic line ratings.
Thank you, Dan. That was really informative. That was a really deep dive into FERC Order 881 compliance. My name is Dragan Trifanovic. I will be sharing a short demo on digital dynamic line rating. This is the newest product built on GridOS at GE to comply with generating the ratings. So let's dive into it. All right, so let's take an overview of digital dynamic line rating. This is the newest GE product that you can see. This is actually developed in order to comply with FERC compliance to basically generate ratings. A lot of utilities that we know, that we talk to, have trouble generating the ratings in the current state. As you saw Dan's presentation and Infosys, it takes a business structure to make this change. So today, let's take a deep dive into how we generate the ratings. So as you can see, from north to south, if we zoom in, we're going to show every utility line, transmission line that's available. But don't limit yourselves on transmission line. The product can actually go into sub-transmission and distribution network, and we'll touch on that real quick. It's very simple. You can see the line, how it goes from north to south, and what the ratings are currently doing. This is based on the real weather data coming into the application. This gives us ability to run hourly updates, and the first point will always be measure point as we get from the weather data provider. These are the weather measured stations that are on the ground, close to where we live, close to our power lines, and etc. The forecast rating is also going to be available to comply with the FERC Order, and we'll get into those. So real simple. As you can see, you can get the ratings, you can get the gain, and this is capacity that you're currently getting out of your current infrastructure as we operate safely. The product itself has the ability to cover all your assets. So not only the transmission lines to go with the compliance with FERC 881, it also has the ability to get into sub-transmission and also facility ratings. So simply on and off, you can manage any of these as you feel comfortable with it, or if you're doing a construction project or an upgrade, or deferring that eventually through utilizing software such as this. Conductor models are shown. Fairly simple, something that's familiar to the industry. You already do this on a yearly basis. You re-rate your ratings based on those conservative values that they've touched upon. Again, gives you ability to flexibly manage those in the software. And not last but least, we also cover the facility ratings, so we can get really deep into the substations and find other limiting factors that could limit your performance or capacity across the network. If you click on real-time ratings, we'll have the ability to see real-time data coming as we operate now and in the near future. Short-term future, as we get into the actual ratings, what's going to happen in the next 24 hours. You can see the operating lines and the normal ratings and emergency ratings, as you can see on the right-hand side. Identical, let's look into the future. Let's look into 10-day forecast. This is also for compliance for FERC Order 881, so we can see how the lines are performing in the future as we look ahead in 10-day forecast. Also, last but not least, in settings, the user has the capability to either run a simple compliance AR mode, or you can go into a full DLR mode anytime you wish to get extra performance out of your capacity lines. Thank you very much.
Now that we've seen GE's dynamic ratings, RTDyne, our digital dynamic line rating application, and our limit exchange portal, I'd like to go through a slide of how all three of those are going to interface with each other and then provide a full FERC 881 solution. So an extended solution. So again, like we mentioned, that for the minimum for requirement would be the EMS AER limit management, which is our RTDyne application. That makes sure that takes all of your limits, either be they ambient adjusted ratings or dynamic line ratings from field sensors or our digital dynamic line rating application, and ensures that the correct rating with best data source is being used at all times. The digital dynamic line rating acts as an enhancement to that, so you're getting even more capacity on your transmission system, so you're more reducing the congestion on the grid, as well as unlocking your full footprint by a single software solution installation. It also is going to compute your 10-day forecasting, and it also allows you to be future-proof compliance with NERC in case they decide to go to a full dynamic line rating mandate in the future. And then our limit exchange portal allows you to ensure that your transmission owners and your ISOs are all operating to the same ratings by transmitting your real-time ratings back and forth between your EMSs and market systems, as well as your forecasted ratings. And then it also acts as the repository for any future audits or data interrogation. So I'll take a brief demonstration on the EMS application that'll take use of the digital dynamic line ratings and how that's used inside the EMS application. So I'll be sharing my screen. So right now we're looking at the RTDyne or dynamic rating application inside of our EMS. We've got a handful of lines that are included into our dynamic rating application. So just in background, so our application really is kind of meant to be ran under the hood, so it's kind of behind the scenes application. So I'll kind of dive into the details to show you how the application works. So as an example, this line 148150, we currently are using an ambient adjusted rating table on this line. So it's a very small table. It just has a rating of 20 degrees ambient and 50 degrees ambient. The current temperature is 15. It's going to use the next most conservative rating set. So it's going to pull this first rating set out of this table for normal, emergency, and load shed. So you can see here what the effective rating is at 1800, 1900, and 2000. If I come in and I can manually change that value to show how the application works. So if we were at, say, 35 degrees, then the application is going to move up to the next most limiting rating set. So it's going to pull the 50-degree temperature set. And so it's going to start using the 1600, 1700, and 1800 ratings. So you can see that that's currently the effective rating set that's being used for normal, emergency, and load shed. If, say, my temperature set was to fail, if I had a bad telemetry on my current temperature value, the application works that it falls back to the next lowest priority with good data quality. So we would fall back to our seasonal rating set, or we would fall back to our nominal rating set. To kind of see how the application works in real time, I've got a display pulled up here. So we've got our Douglas to Hanover transmission line. Basically, we've got a demonstration here where we're using a field-based digital dynamic line ratings. You can see that our ratings are changing over time due to the changing in ambient conditions. The RTDyne application is using the SCADA API to write, like I had mentioned before, to write the ratings from RTDyne to SCADA and also to our network application. So you can see here that it's writing in these limit values for the normal, emergency, and load shed. And as those field conditions change, we're going to be updating those ratings consistently. As an example, for the fallback method, so if we have poor data quality, so if my field sensor, the connection to them, the telemetry to them fails, and so I can mimic that by putting my normal ratings as not in service, then I'm going to pick up that those ratings have failed, that those telemetry field-based ratings have failed, and I'm going to write in a new limit value. So I've gone from the previous dynamic line ratings value that was giving me a 10,090, so that's based on whatever the ambient conditions are, and now I've dropped back to a seasonal-based rating set, which is more conservative because I've lost the telemetry to my dynamic line rating application, and so I'm ensuring that I'm always operating to a conservative data set based on the most best data quality that I have at the time. So if I put that back in service, I will see that value come back to normal. And again, these values are also written not only into SCADA, but they're also written into our NADAP, our network applications. They're written into our state estimator, contingency analysis, our multi-time point look ahead. So all of our ability to look into the future and see what our ratings will be over the next few hours or days to ensure that our system is always in a reliable and resilient state. Over to Doug.